Can you think of anything that might be invisible? Like maybe the air is invisible, right? We like know it's there because we can feel the wind, right? But how about a force? Not like may the force be with you like Star Wars, but can you think of something that is completely invisible that's a force? We're going to look into today something that goes with this learning target. I can recognize evidence that fields exist between objects even when the objects are not in contact. That's pretty awesome. So let me show you something super cool. And you can do this at home if you want, if you have a really good magnet and a paper clip. Watch this. Ta-da! Not touching the paper clip, but I have a magnet in my hand and a paper clip is appearing to float, isn't it? So there must be something in between magnet and the paper clip, right? It's an invisible field, right? A magnetic field. Well, magnetic fields you can't really see, right? Because they're invisible. How about another field that you can't see because it's invisible? Let's look. Ah! Hang on, I'm busy breaking stuff. This would be the sun and the earth and the moon. It's just a model, but what field that's invisible, what force is at work here in space? Did you guess gravity? You got it. And you know gravity exists because when I wasn't holding this paper clip up with the magnet, it fell down. All right. We're also going to talk about something called a permanent magnet. Say it with me. Permanent magnet. And those are substances that are permanently magnetized. This is a magnet. It's permanently magnetized. Doesn't matter what I do to it, it will still be a magnet. Okay? It will still pick things up. And it will still... Oh, look how strong it is. That's awesome. It will still pick stuff up. There's another... Okay, let go. There's another kind of magnet that's called an induced magnet. Say it with me. Induced magnet. An induced magnet is a substance that becomes magnetized when a magnet is brought near it. This is super cool. And it has to do something with something called a magnetic domain. Say it with me. Magnetic domain. A magnetic domain is when the atoms line up with their north poles facing the same way. Today, when you do notebook page 43, you're going to draw a diagram of a magnetic field that makes an object appear to float, kind of like our paperclip, right? Or you're going to explain what the interaction at a distance means and give an example. So like interaction at a distance would be, again, like these two things, the magnet and the paperclip, are having an interaction at a distance, okay? And there's a force in between them. Or the planets have an interaction at a distance. You don't really think about it, but they do, right? Because of gravity. That's what makes them orbit each other. But now we're going to talk about an induced magnet and a magnetic domain. So let me show you this pile of pins. Pins are usually made out of a steel which has iron in it. But if I touch this pin to all these other pins, it doesn't really pick them up. Okay, does not really pick them up. You can tell. I can try another one if you want. Doesn't really pick them up. Doesn't really do anything. Okay, so what I'm going to do is I'm going to make an induced magnet. I'm going to line up all the atoms in this pin. So I'm going to put my magnet this way. And I'm just going to go one direction with this pin. And what I'm doing is I'm lining up all the atoms in the pin so that they're facing the same direction. And I'm going to temporarily magnetize this pin. It's called an induced magnet. Watch this. Ta-da! It picked up the pin. Okay, means it's magnetic. Okay, so now let me not confuse us with these other pins. Let me drop it, And what will happen is when I drop this pin, it went all over the place. When I drop this pin, I promise you I didn't switch pins. When I drop this pin, what it should do is demagnetize it, right? Because you can bang it and you can, I'm just going to bang it with my cup there a little bit. And hopefully what it does is it knocks the atoms out of alignment and it's no longer a magnet. I don't know, let's see if it is. We'll see if we can't pick up something anymore. Oh, it still is. It stayed pretty good. Oh, it's losing it. Let's drop it some more. Nothing. Okay, so we moved those atoms out of alignment. So one of our important terms today was magnetic domain. And this is when the atoms line up with their north poles facing the same way. And what we did was we lined up the atoms in that magnet so they face the same way in that pin. And we made it an induced magnet, which was a temporary magnet. And then we used our permanent magnet to actually magnetize it. You're also going to do page 44 today. Yay, right? So what I want you to be able to do is manipulate and test an electromagnet. So our key term here is electromagnetism. Say it with me. Electromagnetism. This is magnetism resulting from electric charges in motion. So we're going to look at electricity and how electricity and magnets are related. This term is electromagnet. Say it with me. Electromagnet. An electromagnet is a metal core made into a magnet by passing electricity through a coil surrounding it. Usually it's wires surrounding it, okay? On page 44, this is notebook page 44, notice it's not highlighted, you're going to explain how an electromagnet works, or you're going to draw a diagram of a simple electromagnet. And remember to use labels. Oh, look at me. Remember to put our parentheses in there. Okay, so today you will do a couple things. You're going to do notebook page 43. You're going to do notebook page 44. You're going to watch 2 short videos, one about an electromagnet and one about Bill Nye explaining all kinds of cool stuff about magnets. And remember, he has really cool demonstrations, so it's super important to pay attention. And also it will help you answer some questions in your notebook. Then you're going to do a lab. It's a virtual electromagnet lab. You're going to do it, and then you will answer some questions and submit on a Google form, submit what you find on those questions. Okay, so have fun with playing with the virtual electromagnet. Pay attention to Bill Nye. He's a smart, super smart science guy. And do your stuff, get your notebook done. We'll see you soon.